In this demo, we are going to program our basic sniffer. But wait, before starting on this, I want to pay your attention about the basics of networking. Everything that we deal with in the end is either 0 or 1. When you receive from the internet your network packets, your home switch is going to deliver it to your computer as electrical signals. And guess what? All these electrical signals are captured by your network interface card, and it will send it over to your CPU. This monster only understands zeros and ones, nothing else. And this is what we are going to see in this demo. Let's see how this program works. I will start with the Python keyword, followed by the name of the program, which is basicsniffer.py. No arguments needed for this one. Finally, press enter. Let's open a new terminal window and try to execute a ping request. Here I'm just pinging my home router. Now take a look at our sniffer output. Guess what this is? Yes, you're right. It's binary code. Don't worry, we will decode all this in the next demo. For the time being, let's take a quick look at the source code for this simple sniffer. As you can see at the top, I imported the socket library. I did my best to simplify the source code as much as possible, so you would understand the basics. I'm not even using functions in this example. No worries, I will refactor this code in the next demo. First, I declared the sniffer variable by instantiating the socket object, like we did in the previous module. But in this one, I'm using the raw sockets. And I will be listening for ICMP packets. You can also use TCP or UDP. But for this one, I will use the ICMP protocol. Next, I'm using the binding function to bind the sniffer object to the local host machine. You already know what 0.0.0.0 is from the previous module. Now, what about the port 0? Well, port 0 is officially a reserved port in TCP/IP networking. However, port 0 sometimes takes a special meaning in network programming, particularly in Unix socket programming, where port 0 is a programming technique for specifying system allocated ports. Did you understand what I just said? Well, I'm going to make it easier for you. Instead of writing code that searches for an available port on the local system, you can instead specify port 0 as a connection parameter, and the operating system will automatically search for the next available port in the dynamic port number range. In the next line, I'm using the setSocketOptions function to make sure that the IP header is included in the packet. After that, I print a message to the user that we are listening on, and finally print the received packet to the user. That's it, folks. This is the basic of sniffing using raw packets in Python. Wait, we're not done yet. As I mentioned earlier, we will decode all the binary data in the next demo.